Hello everyone. So I'm making this video on domain and range upon student request because this is a relatively new concept for the IGCSE maths course, but it's a very important topic since it's the backbone of functions. It's what makes up functions, and therefore I'm making this video to help you master this concept. So before we start, we need to understand what the terms domain and range actually mean. So the domain of a function is the possible set of input values or the possible set of x values. And so if the domain is the possible set of input values, that means that the range must be the possible set of output values or y values. The reason why we can also call the input value as the x value and the output value as the y is because if we have a graph of a function, let's say the function looks something like this. So now if we look at the set of x values to find the domain of this graph from the sketch, what we do is we look at the x values that this graph spans over. And that would therefore be x is greater than or equal to 0 because the graph spans this part of the x-axis, which is basically x is greater than or equal to 0. And so similarly, if we had to find out what the range is, we look at what y values this graph spans. And so that would be, and so the function, the range of this function, you could write it as y is greater than or equal to 0. Or f of x is greater than or equal to 0. They both are the same. Because if we look at this, because now the graph spans this part of the y axis. So now if we modify this function a bit, or this graph a bit, and we added in this negative part too, or actually let's say we have it continuing like this. Now the domain remains the same. You can see that because the possible x values that the graph is defined by is unchanged, whereas now if you look at the range of the function, the range would be, now it also includes this negative y-axis part. So now the range of this function would be any real number, and the way we write that is y is any real number. Essentially, y is a member of the real number set, and that's how you write that for the range. And that's how you would find out the domain and range from a graph. But another interpretation of domain and range, another way to understand it, is through mapping diagrams. And what a mapping diagram is it basically has a space for the domain on the left hand side, and it has another space for the range. And so we have the possible input values, the possible domains on this side, and on the other side we have the range. And what this essentially is that after applying the function f of x to the domain, you get the range. And so therefore we connect the domain, each domain value to its respective range value. So in this case, we can see that the function is clearly f of x is equal to 2x. because each range value is double of each domain value. And so this mapping diagram shows us that shows us what the domain and range of the function is for these values. And so if the domain was limited to these three values only, the range would be these three values. And so now if we move on to the topic of limiting domains, sometimes domains are restricted and the most common example of this is if we have a function f of x is equal to the square root of x. F of x is equal to the square root of x. We restrict the domain to x is greater than or equal to 0. Since you cannot take the square root of a negative number, x must be greater than or equal to 0. So that's one example. Another example is when we have f of x is equal to 1 over x. And so for this one, pause for a moment, think about what the restricted domain would be. So now if you've done that, you should see that the restricted domain here, x, cannot be equal to 0, because the denominator of a fraction can't ever be equal to 0, because that would be undefined. And so we can also represent the domain. As you can see, we can represent the domain using an inequality sign or this symbol, not equal to. And so now if we extend this example to a more complex fraction, let's say 2 divided by 4 minus x. Now what would the domain of this function be? Well, we still can't have the denominator equal to 0, because that would be undefined. So we set that equal to 0 to find the invalid x value. And we see that x equals to 4 produces the denominator as to be 0. So therefore that must be restricted from the domain. And so we can write it as x is not equal to 4. So always be careful with these, between these two. Make sure you're able to differentiate between them and find the domain and restrict the domain appropriately. And so, but sometimes a domain may be restricted by choice. These ones are restricted by mathematical convention, because you can't have a square root of a negative number and you can't have a fraction with denominator 0. But sometimes, let's say we have a function f of x equals to 4 plus sine of 2t. So let's say this function, it could be anything. Let's say it measures the length of your shadow throughout the day, where t is the time of hours. So this would be f of t. And t is the time in hours. So therefore, the domain for this would be t is between 0 and 24, because there are between 0 and 24 hours in a day. And t cannot be greater than 24, nor can it be less than 0 for each day. So hence, this would be the domain. We have restricted it by choice here, just so that it makes sense, because in a day we only have 24 hours. Right, so that's all about restricted domains. And of course, each domain will also affect what the range is. So if we restrict the domain, let's say for this, let's go back to this 1 over x example. Let's say we restrict the domain to x is greater than 0. So if we restrict the domain now to x is greater than 0, that means that this fraction can never be a negative number. And so the range of the function would also change. And f of x will be greater than 0 as well. Whereas if you consider the normal case where just 0 is restricted, you can also have x equals to negative 4, for example. And then the f of x value would be negative 2. So always be careful when they have restricted the domain. Always consider how it would change the range as well. They'll often try to trick you out like that, catch you out. And one final thing I want to talk about is when we're given a graph, it's important that you're able to differentiate between a symbol like this. So let's say we have a graph that looks like this. A straight line graph. This is the value 5, the y value. And the x value is, let's say, -3. So the domain of this is what x values there are for this graph. What x values does this graph span over? Clearly, we can see from the graph that the only x value is -3. That's the only x value of this graph. So we can write that the domain is x equals to 3. And now if we look at the range, it may be tempting to say that the range is y is less than or equal to 5. However, we have this unfilled circle. And if you remember from your work on inequalities and number lines, an unfilled circle means that the value is not included. So therefore, instead of the range being y is less than or equal to 5, it's actually y is just less than 5. So it's y is less than 5. So y can be, as you can see, the graph spans any y value less than 5. And now if you change this slightly and added in if you shaded this in now the 5 value is included. So we can see the range is now y is less than or equal to 5. So it's important that you remember this concept of unshaded and shaded circles. That's quite important as well. Okay, so now that we've done, that's all the theory you need to know for the course, the new syllabus change. So now if we go to a past paper question, which I've extracted from a specimen paper, we're given that the domain of f of x is limited to these 3 values. So the function only exists for these 3 x values. So they're asked to find the range of f of x. So one way to do this is to consider as a mapping diagram. We have the domain -3, 0, 2. And then we have the range. And we want to find what values of the range will produce. So all we do is we substitute in each value of the domain into the function. So the first one will be f of -3. This will produce the first value of the range. And f of -3 is 3 times -3 minus 5. Which is -9 minus 5, which is -14. So that would be the first correspondence, first link. So now if we do it for f of 0, the next value of the domain, f of 0 would be 3 times 0 minus 5, which is -5. So that would be the next one in this diagram, mapping diagram. The final one, f of 2, would be 3 multiplied by 2 minus 5, which is 6 minus 5, which is 1. And so therefore that's how the this is how the mapping diagram would look for this function. Well, we connect each domain value to the range. So therefore you can see that the range is these 3 values. And so we write the range like this. And it's important that you write them in this order because we're given the domain in this order as well. So they must correspond to one another. And so yeah, that's how you would work through that paper, past paper question. You might get something similar like that in your exams. So now I want to leave you guys with one question to think about. So I'm giving you this function that looks like this. So this y value is 5. Over here we have -2. Here we have 2. And let's say this is -3. So now that you have these values, I want you to tell me in the comments, let me know in the comments below what the domain and the range of this function is. So let me know in the comments. This is quite a challenging question. Remember to use inequalities to represent your answers, and remember the difference between the shaded and unshaded circle. And let me know in the comments. Drop your answers down below and see if others agree. But other than that, that's all you need to know for domains and range. For domain and range, I hope this was helpful. If it was, please like, share, and subscribe. And feel free to drop down any other video requests you have, especially since I know the exams are coming up now. Always feel free to drop down any questions you have. And yeah, that's it for this video. Thank you, and I'll see you in the next one.